So in the previous class, when we started off with set theory, we basically firstly went into the definition of a set, wherein we defined a set as a collection of distinct objects or elements. Then we went into the different formats in which a set can be represented, and we saw the roster format and the set builder format. Then we went into the different kinds of sets possible, like the empty set, a singleton a set, a finite set, an infinite set. Then we went into the different categories of sets, like the universal set, subset, proper subset, improper subset. Okay. And then, last but not the least, we went into the operations on set, wherein we saw how a union, intersection, difference, and complement can be different operations that are performed on sets. Okay, so this is what we covered in the previous class till now. This class, we go into more basics for set theory, and we discuss about, firstly, a definition that arises from the operations that we have. So we define a very important aspect in set theory called power set. So let's talk about power set. Now, what is a power set? A power set for any set is the set of all subsets. Okay, so it arises out of the concept wherein we discussed subsets. So from the category of a set, let's define another set which gives us the set of all subsets. Okay, so if I have a set A containing two elements A, B, the power set defined as P of A is basically, firstly, the null set, which doesn't have any element. Secondly, taking exactly one element out of the two elements. So I'll get two sets like that, and a set which is the set A itself. So the set of all subsets of A will contain 2 to the power of the number of elements that are contained in A. Okay, so 2 to the power n will be the cardinality of power set of set A containing n elements. Okay, so a set containing n elements will have a power set which will contain 2 to the power of n elements. Okay, this blank set is also called phi. Okay, it's called phi. That is, no element is there in the set. Phi is a subset of any imaginable set. Okay, nothing is a subset of any imaginable set. Any set having one element, 50 elements, infinite elements, all of them will have phi as a subset, right? So that's one of the subset in the power set. Okay, so that's about the power set. This is one more category in the set of all sets, right? Yes, correct. So if I write Deepak, so basically for a power set, this first, second, and third are proper subsets, and this AB is an improper subset because this AB is the set A itself. So the set A itself is also a subset of itself, right? It's a improper subset, but it is a subset. So the set of all subsets includes the set itself also. So I can write it down in this way, that A is a subset of its power set. Okay. A is a subset of its power set as well, right? Okay. Now is a good time to understand the different kinds of sets which are commonly used in your entrance examinations.